Awesome. Okay, cool. Maybe I will share my screen just for a second to show the notes and agenda so far, and we can see if there's any other points that need to be added here. And just wanted to pull this up for anyone who's watching who is interested in joining the Luna Swarm. We do have kind of an open contributor list, so feel free to dive into these notes, get caught up on what's gone on in the past, and yeah, get involved because we need more cadCAD modelers, and this is a really exciting directly applied use case. So one thing that I wanted to talk about quickly before we hand it over to Luke to discuss the latest model progress and have some Q&A with Zargam and other community members who have questions about it. Just identifying, some of the various stakeholders who are interested in the Luna Swarm process and how we can manage meeting the varying needs of these stakeholders. For example, OneHive community members who may wonder about the impacts of policy choices on the economics of OneHive versus stakeholders who are interested in the technical specs that come out of these modeling decisions, and just making sure that we have an idea of who has input and where that kind of community insight and transparency come in. Okay, a couple of notes there. So regarding like the technical specifications that come out of this, so what questions come out of the modeling, what questions are answered by the modeling, and how those formulate into hard tech specs in the OneHive community as applied. And oopsie, there we go. And yeah, how those impacts could play out on the OneHive currency and the price of honey and so on. So just wanting to kind of open that up. I don't know that there's a ton that we need to identify with the stakeholders here, but if there are any questions or concerns about how the modeling relates to various stakeholder groups in the OneHive ecosystem, more than happy to hear any concerns or thoughts about that.
I guess I would just say, in the case of the supply policy, issuance policy, we did some modeling work to kind of figure out the basic mechanism, and then use that to inform a requirements doc that Will then went and implemented a first version of in Solidity. So from just sort of a example in terms of how this may work in the future. Or has worked so far, is that rather than starting and saying hey, this is what we're going to implement, we started first by exploring the design space, creating a model, looking at how that particular mechanism performed in the context of that model, before going into actually creating a technical specification or implementation. And right now we've got this kind of technical implementation and specification that we're reasonably comfortable with in terms of the mechanism. We're continuing to do modeling, and so in theory we could still change course and decide on something different, but we're pretty confident, and now we're trying to figure out how we would parameterize that mechanism and create a more formal proposal. I've been kind of aiming to create a formal proposal, and it'd probably happen sometime in early January, where we'd say, based on kind of our research and kind of modeling efforts, this is the proposed mechanism and why. Here's some of the rationale. What are the things that we assumed? What are our sort of expectations? And what are we suggesting in terms of parameter choice? And we'll see how that goes in terms of building consensus, because the topic of issuance has been an important and very controversial topic where everybody has very strong opinions, but doesn't necessarily have a super strong reference in terms of how they came about those opinions. So we'll see how that process goes, I think, as we try and try and actually adopt the policy that we've been working on.
Hey Luke, are you?
Sorry, just one thing I was going to say. We've been doing this huge parameters deep dive on the TEC side. So if you wanted to take a look at any of the documentation on the TEC forum, if you want to pick up any of those kind of templating of the discussions, and also haven't had like a vote or anything, but it's been a really great kind of organization of the topics, and like if that's helpful at all.
Definitely, we'll check it out.
Hey,
You guys
Luke,
are determining like how to configure the bonding curve in conviction voting, essentially.
Yeah, and we also have we have so many parameters. I think there's like 20, because there's also the exit tribute, and there's a lot, but we're trying to organize it. So it's already on the forum in the deep dive, and then we're going to do like a TLDR. But if you wanted to have a look at some of the discussions, like maybe it's helpful. No.
Definitely share on the Luna channel. What were you saying,
Okay, I will.
Atrocity?
Yeah, I was just wondering, are you using the growth branch on this one? I haven't had a chance to look at that one yet. I looked at your first one pretty detailed, and we talked a bit about that one, but I never got a chance to circle back around and look at the growth one yet. Is that the one you're on now?
So right now, the most recent one is the Stochastic branch, which is sort of a slight modification from the growth branch that
Okay.
we'll kind of dive into, I think, when we get into the sort of like the review phase. I still need to kind of clean it up, and I asked for, I guess there's a tool for setting up like a cadCAD repo in a pretty structured way, and so I'm going to try and create like a Luna Swarm model like repo, and the ones, rather than just using these like branches that just hang and don't get merged, I think we'll try and adopt the structure that was used in the conviction voting model repo, where you have like versions, and the versions are in folders, so that they, like, even though you're using get and get is version controlled, you kind of have a easy to like look through sort of history of like checkpoints of the model where you're like exploring different things or making different assumptions.
That's actually super important in cadCAD. It's one of the things that led us to some additional tools we've been building in Block.Science around managing the history of models, because unlike software, where as a rule you really only maintain old versions insofar as people are still using them for scientific workflows, the old experiments are actually really important. The history of the experiments contains some like unique information, and so making it discoverable and even like can be revisited if you ran a set of experiments, and even if you changed the code to run different experiments, you want the hashes of the versions of the repo, that contained those experiments to be, well labeled and discoverable, so that you can switch to that version and, say, view that experiment again, or even, fork off of it. So it's in a lot of ways you're like maintaining more of a tree of work than you are maintaining a line of work. And it's not just the last point in the line that you care about, but really the whole history of the tree. And obviously that adds a lot of version control management complexity. So it's something that we've spent a lot of time and energy thinking about. And this model file structure is just like one piece of that. It helps some. But anyway, sorry, I'll stop. But I just wanted to hang in on this, because it is sort of critical to the nature of the work to understand that it's, if you've ever done work in a scientific lab, you keep a literal lab notebook. And that sometimes you refer to an experiment you did 6 months ago to help you understand something that you're seeing now. And you don't want that to be lost. You want it to be, recoverable, where you just look and see, okay, that's this one. Let me click on it. Oh, there it is. What did we see? Okay, that makes sense. And then you bring that knowledge back to the front of your mind and account for it in some future decision.
What I was thinking, and you can go ahead and commit me to creating that repo this week. I really should have gotten to it this week, but I didn't. So it doesn't need to be a nebulous eventually. I'll do it this week. But I've also been working on the wiki this week, and I haven't really tackled the Luna Swarms. There's a whole bunch of other stuff that I thought was a slightly higher priority. But I think we can include the like meeting notes and the recordings there, as well as sort of like models that we're working on, their like goals and iterations on those concepts, including like a page in the wiki that sort of does kind of the exploration and analysis of that like iteration, and then references the notebook. So for people that like aren't gonna install the dependencies for cadCAD or run the thing, they can just go to the wiki page and see that iteration and sort of the analysis behind it. I think that will make things a little bit more digestible, and kind of make all of the work that we're doing a little bit more visible in terms of a history of things, and can be referenced in other places more easily. Because what I've noticed is even on GitHub, like the plots don't actually render in the preview. So like if you're doing like an analysis kind of workflow, you miss a bunch of the data. I've noticed, and I'll end up having to deal with this in the like current version. I'm using like Plotly Express, which was used in the cadCAD course. And now that the model like data is bigger, it basically like wipes the plot, so you have to like rerun the cells every time you want to see the data in a plot, which is super annoying. It might have to switch libraries or something to like fix that workflow.
I mostly use Seaborn and Matplotlib, which are like more like they're a little, they require a little higher level of dexterity in the sense that they're more basic. Plotly was essentially made to make cool things easy, whereas Matplotlib and Seaborn are a little bit more hands-on.
Plotly seemed like it was a good place for me to start since I don't have experience with those other ones, but it sounds like the rendering functionality for like Matplotlib and Seaborn is more static as opposed to interactive and a little bit less heavy.
Exactly. And also just keep in mind that, data viz is a whole domain in its own, and what you're doing is producing data. So if you get to the point where a particular model was super useful from a community perspective, you might actually run the model, generate the data, drop it in a backend database and read it into some JavaScript in D3. Like, not that you should go do that right now, but just understand that the model, the data visualization layer is its own layer, and you should just use whatever works for you in the context you have. So Plotly, as long as Plotly serves your needs, Matplotlib and Seaborn as long as they serve your needs, and then, obviously in some extreme, more front-end oriented cases, you'd find yourself even just kicking the data into a format where it's stored and accessible to like a JavaScript, if that's what you were more comfortable with. And you could, again, just read it and plot it using JavaScript libraries, if that was, again, I'm speaking to the group as a whole, since I know that there's a lot, I think there's a bit more JavaScript than Python in the like crypto communities, just as a matter of context. There's one other point about plots was if you go to NB Viewer, which is a website that will render notebooks, it's pretty cool. You can, if you have an open source repo, then you can actually see stuff. So it might not render nicely with Plotly. I'm not quite sure how it handles Plotly, but for the more standard Matplotlib and Seaborn plots, it renders much more nicely than if you look at the same things on GitHub. But you can literally drop the GitHub URL in the NB Viewer field, and you will get literally it's Notebook Viewer. So if you're even linking documents, you might actually want to link to the NB Viewer version rather than the GitHub version, so that it renders better.
Gotcha. Cool. I'll check that out.
Just like a hack for sharing. I try to send people NB Viewer links if the thing that I'm linking them to is in a public repo. Cool. Sorry. Go ahead.
Cool. Yep. No worries. I think that's great start. I will stop sharing and we can hand it over to Luke to discuss more about the model specifics and some Q&A with anyone who has comments or questions.
Yeah, I mean, actually, before we do that, I wanted to ask if anybody else had anything they wanted to, because I know it's easy for us to hop into the models that Luke's been hacking on and talk through them through pretty much the whole period. So before we dive into that, if there are any other project items that we want to discuss, I want to do open floor first before we burn the whole session, because we will. Of course I will. I just shut up.
I don't think we need to spend too much time on this, but I think there's probably an appetite. I think Luke included. Don't mean to speak for him, but fee structure on HoneySwap. There's been a lot of discussion about what is the ideal fee structure to garner liquidity and then also were you about to say something?
Yeah. I'm glad you brought it up. I definitely, like you said, you don't mean to speak for me. That's definitely, I think, the next priority in terms of modeling. I've actually started to think a little bit about how I would approach trying to structure the model, and have been meaning to sort of write that up and share it for feedback.
There's one.
I think. Go ahead.
Sorry. There's one PM item. I don't know if you want me to say it now or bring it up at the end in reference to time tracking, and I'm gonna be creating a system for that. So I just wanted to double check if there are any participants that we are not aware of. As far as the proposal passed, we have funding for the project. I'm going to work on putting together like a time tracking sheet or system. So I just want to be aware of who are the paid contributors, and then that way we can put something that's more visible and transparent, because people have asked about it and may want to jump in as well when they see like a structure for that.
Okay, I think we should do it before also. I'm going to comment on the first question, then we would go to the second one. For the fee structure, I mean, what I would want to do is find somebody who is interested in creating a fork of the Uniswap model that already exists, and try to link it up with data from HoneySwap as a starting point. Just to I don't know if anyone's seen, there was like a video made like a year and change ago by Marcus, which took the Uniswap logic. He translated it into cadCAD, pulled data from the urth pair, and then showed the time varying state space using a video, including the impermanent loss on a small plot and some interesting stuff as part of what the demos and tutorials for cadCAD. And I believe that's already been upgraded, even though it still uses the old data. So it should run in the cadCAD current version. And the first step there would actually be to just go look at what changes would need to be made in order to reflect HoneySwap and to sort of reproduce the backtest. Basically run a few months worth of transactions on HoneySwap through the model and sort of verify that it matches with reality in a way similar to what he did with the historical urth pair. And at that point, you would have a piece of machinery that you could use to evaluate alternatives. So if you wanted to change the policies, then you would say, well, over that period, if the policy had been this, what would have happened? Now, we have to be careful with that, because remember that the behavior itself would be treated as exogenous at that point. You'd be using the real historical sequences, and they would potentially have changed if you had a different policy. So then the next step is to start to think of it as a feedback loop and ask how the behavior might change as a result of the policy. But step one would be to sort of take that code, translate it and backtest it, then to start playing with policy modifications, and then start playing with behavior modifications in response to the policy modifications. So it's a pretty straightforward roadmap for digging in on that if somebody were interested in it. It's still a lot of work, but at least the big chunks of steps are straightforward. I hope that helps. I don't know if it feeds into Jess's question, like if there's work and people are interested, how do we get them involved, track and compensate, etc.?
It's interesting actually, but I'm not sure if I need to dig deep before I say I will work on it. So it's like a lot of work before you commit in it. It's not like easy stuff. You don't want to give your word to people, then after that you disappoint them. So yeah.
For sure. I'm not asking any of you to commit now. I'm actually just saying, honestly, we've found that with modeling in particular, even just writing scope can be a month of work. I've done client contracts where I spent over 2 months just helping them figure out what the heck we're going to do. Because it starts with a vague policy question and it becomes a much more formal analytic question, but it doesn't do that overnight. So I would argue that it's important to understand even the work implicit in figuring out what the work is going to be. In this case, I'm giving a sort of starting point, but even that starting point is just, again, pull the model, get it running, figure out how to swap out the input data and possibly refactor it slightly to match the logic of HoneySwap, which is itself potentially a considerable project. That would become the building block for step 2, where you started changing the policies and looking at, what might have happened if the policy was different. And then finally, the most complex thing, but the thing that ultimately helps answer the question is evaluating how the behavior might have changed as a result of the policy, kind of going to a closed loop model, something that helps us say, but if we increase the fees, then maybe volume would go down, and if volume went down, then we'd actually make less, even though we increase the fees. And that's where the liquidity pool type fees start to get tricky, because you could lower the fee but increase the volume and increase the net, or vice versa. So there's like second order effects to kind of try to tease out, and you don't really know for sure. But one way to deal with this is to try policies like and to test out policies like, well, if the volume is, rising, then maybe we increase, or maybe we decrease the fees, right? Like if the volume is rising, increase the fees, which will suppress the volume but make more money per period. And like, I don't know if that'll work better, but the way that you level up to analyzing that would be through the steps that I described.
Mustastri, do you want to work on this? Maybe we can track it down together.
Yeah, I mean, I probably don't have as much free time as some others do. I went through the cadCAD Python, and I'm actually going back through it again, trying to believe it or not, I'm not that great at it, so I'm trying to relearn. I'm trying to learn a little bit better and installing that stuff on my computer, but I haven't made it as far as getting into the actual cadCAD stuff yet. Just still on the early end, so I don't know. I can try plugging and chugging through it. It's definitely quite a feat compared to what I'm used to.
Yeah, I'm not sure. Yeah, I will have to look into it before speaking about it.
Yeah, I think we would have to set up. For myself, I'd have to actually schedule meetings in advance. I can't just do ad hoc stuff.
Yeah.
Be a little bit more structured with if we work together on it.
Yeah, sure.
So yeah, basically, I just wanted to ask Luke, are there any new contributors as far as paid modelers or anybody else we need to be aware of? Otherwise, I'm just going to set up a time tracking sheet for people to report hours if there's anyone. Maybe there's no one right now, but
I think there's anyone right now, but getting the structure set up, I think, will make sense, and then will probably help us figure out how to onboard people.
I'll do it in the next week before the next meeting. There is one next week because it'll be Christmas.
You guys skip that, I think.
Still. Okay, model proceed. Admin finished.
Okay. Yeah, can you guys see my screen? I've got the notebook up.
Yep.
Cool. So, based on the conversation we had last week, kind of wanted to try and tackle the making the price function more of a stochastic process, kind of based on that feedback, and sort of exploring what that would look like. And so what I ended up doing was kind of keeping the existing sort of pricing function that we had before, and treated that as sort of like a target price in the model that we track, but not necessarily the price that is used to determine the impact of production or the conversion rate for inflows. And instead had the spot price or the actual price be a random kind of random walk from the current price or from a starting price that gets a direction and magnitude. The magnitude being kind of like a normal distribution with variance, which is what I kind of seen in that other model that was linked, and then the direction being pulled towards the target price some percentage of the time. So depending on what the parameter for that percentage is, it'll be more or less correlated versus a completely random walk. And so I think right now that is configured to be 75% of the time it like goes closer to the price target, and 25% of the time it moves away. And a variance parameter of 0.25.
Just as a note, though, if you're just using -1, you're doing correlated and anti-correlated. You don't actually have uncorrelated. Uncorrelated would mean it wasn't moving towards or against, it was just random, right? If I saw that correctly, you had a -1 and a 1. So a 1 would mean that it moves towards, and a -1 would move it away. But a random would essentially mean that it could be either. It's like flipping a coin that was evenly weighted, right? Does you see what I mean?
Yeah.
It would be like zero. Uncorrelated would be like zero direction instead of 1 or -1.
Yeah, that's fair.
-1 is anti-correlated.
Yeah, exactly. It's moving away if it's not moving towards. So we could make this just be a random chance of going towards or against if it's not moving towards.
Yeah. There's a variety of ways to do it, and I think what you have is okay as long as you're aware that what you're actually doing is asking whether or not you are attracting pulsing. You don't actually have an example. You don't actually have a continuum here. You have with some probability I'm attracted, and with some probability I'm repulsed. Whereas more general distribution would just be like in the range between -1 and 1, where 1 is maximally attracted and -1 is maximally repulsed, but that like 0 is just I'm uncorrelated. Or like I'm not really uncorrelated. I'm random. I'm actually random. I'm unskewed. But I'm also not suggesting you change it per se. I'm just pointing out that this is, again, largely a representation of a dynamic. So it's gonna the system results are gonna inherit from this. So I tend to go with things that are simple and smooth, just to try to like make it a little bit more obvious how that compounds through the system. So I think if I were gonna do it, probably just map I would map that parameter to just the mean. In other words, I would use how do you say, like I would go from slightly repulsive to slightly attractive to uncorrelated, where maybe the parameter itself is the number between -1 and 1, and just put it in directly. Or I guess that's basically, I'm not sure what I would do. I'd probably have to figure out what felt right. But my instinct here is that you have one extra layer of complexity that you don't need, which will make it harder to interpret the effect of the assumption on the results.
Gotcha. Yeah, I think there's like maybe a bunch of different ways that we could implement something like this.
If anything, what you could do is define a method and then make the method a parameter. I know this sounds like the one of the cool things about cadCAD's params object is that it's just a pointer. So if that pointer is a function, if it's a list of functions, it also works. So you could literally write one that's like this, which is very polarized. You could write another one that is smooth, and another one that was smooth in a different way, and you could actually look at the results with the functional form as one of the params. It's a little bit more of a complex way of doing it, but this goes back to our point about, since we know we don't know, and there are lots of different ways, as long as you think that each of the functional forms that you've introduced is, feasible or plausible or representative of something, then you can ask how your policy would behave if that was how things worked. And so you can sometimes pick answers or solutions or parameter selections that seem to be good under all of them. Instead of saying what's best into the scenario I constructed, you can say which one is the least bad in the worst case, where worst case is just whichever was worse of the scenarios you tried. And again, I know it's sort of more complicated to manage that, but that is actually how we usually do parameterization on big projects. We end up creating a bunch of scenarios, none of which we know are true, and we look for the things that are, min-max, meaning they're best in the worst case. And that way we are the most sure that the thing we've done is viable despite the uncertainty about reality.
I mean, there's still some sort of like discretion there in terms of like what we determine is the worst case, right?
Oh, for sure.
Because one worst case is the price is completely random and not correlated at all, in which case, like, why even bother? It's just an unrealistic assumption. But figuring out kind of where those boundaries are that you determine are the worst cases.
Let me rephrase that too. Worst case is defined in some metrics. So another thing that you'll do is you might have some metrics where the random case might actually be good, or like random behavior for a certain types of for certain liquidity pools is great. It's lots of activity that washes expectation. That's fucking great for LPs. LPs want fucking random behavior because it just nets out and makes them money without much impermanence. So like, it's also important to keep in mind that sometimes the scenarios that are best for one thing are worse for another.
Oh, definitely. I meant in this particular instance, that would sort of be an example of a worst case, right?
Yeah. And it's an extreme case. Sometimes even worse. I guess the point I was trying to make is that worst might not be the best terminology. Extreme cases or edge cases are often good to study, especially if you have reason to believe that reality is somewhere in between. So if you're testing for and evaluating at edges, then in systems where you can reasonably say, although I don't know what, I can expect the outcome to be somewhere in the envelope provided by the experiments I ran.
Yeah, so what you were sort of saying is that rather than passing like a parameter here on a specific function, I could create a method and pass the method, and I could create multiple methods, pass them in the params, and then I could see them side by side.
Yeah, and I think in this case, because of how much uncertainty there is around this particular method, that rather than creating p-pol, I would just name that, like, price process, and like throw methods in that list, and then write 2 or 3 different methods, and then just pull the method out of the parameter price process and apply it.
Cool. Yeah, I think that makes sense. In any case, with what we've got here, I think there's still a few more questions that would be helpful to get your feedback on. So with that kind of process as it is, I put basically different parameters for productivity as like a start, which kind of determines how productive outflows are. And I also did in the params like 10 runs for each subset, and then looked at the plots to start to see like the variance in the different runs, so the different levels of productivity and the like possible kind of outflows of those 10 runs. And that was interesting. It was like interesting to see the ones that are more consistent at like higher productivity is in terms of outcomes, the ones that are sort of on the edge in terms of influence of the random process. But in terms of determining kind of a structured way to go about these parameter sweeps in Monte Carlo analysis and trying to find the like band, is there like a good sort of process to use to kind of start to sort through? Because you've got like 10 parameters and there's permutations that are pretty infinite.
So this is like the thing that we spent months figuring out for, and we actually, Jean-Rachid and I have on our research backlog writing some documentation to publish, on archive on like methodological, like computational methodological work that just meets this. This is the thing that I was telling you, that given that you have been sort of like involved as sort of a research partner and that you actually are on our MNDA, that we have some stuff that we could go through with you that's like not yet in a form where it's suitable for public, but it's like eventually I want it to be, on how to do this. It's just that we've done it almost entirely for clients. Like obviously our work stream required us to develop a computational methodology for dealing with this problem. High dimensional inputs, high dimensional outputs, uncertainty, like two kinds of inputs. You got input type 1, controlled input. Those are the parameters that you have. But you have input type 2, modeling assumptions, which are parameters or even the methods like we just talked about. And so what we actually do is we built a process for saying, I have controlled parameters. These are the ones I actually get to set. I have uncontrolled parameters. These are the ones that I model, but in real life I don't know. And then I have the actual dynamical system itself, which is the cadCAD model. And then I have metrics, which are the things I care about. And I might even have many of them, and they might be in tension. So then we end up building these work streams that run large numbers of experiments, which essentially produce something you would recognize as a big data, which is at the experiment level, the parameters that we've chosen as input parameters, the parameters that we've chosen at modeling assumptions, then the whole run runs, and it turns into just one data point per metric, per scoring metric. So then you end up having to run potentially thousands of runs just to collect a data set that says, when I picked these parameters under these scenarios, these were the scores under my metrics, and you end up with a machine learning problem to figure out which of the selections of the things that you're under your control are the ones that are most resistant to the uncertainty in the things that are not under your control with respect to scoring on the metrics. And so we've been doing this, more and more with our clients, because that's essentially one of the things that we get paid to do. Methodologically, it's actually really cool. It's like simulated one. It's like create data in one direction and then process it in the other. So the second half starts to look like a data science problem. And Danilo, who I think you've met, has been really instrumental in operationalizing that. And then with Block.Science, we've actually been building some infrastructure to streamline. So we have our internal alpha that we're using, or just about to be using, for cloud-based setting these up. And we have a plan to release a beta, which will be a little bit more feature rich, and we'll roll up to something that we're going to expose to people. It's a platform where we're going to actually have to charge money, because we're going to be using cloud-based compute to execute large-scale experiments. But yeah, you're moving into supercomputer territory. We're not actually using supercomputers, but effectively what am I doing? I'm saying simulate a bunch of alternate universes, generate a bunch of data, and then back out which universe you want to be in. But by the way, you only get to pick some of the variables in that universe. The other ones are out of your control, and you don't know which one you're going to get. So, I'm not suggesting that every complexity, but to be clear, like when you actually get to parameter optimization under uncertainty in this mechanism design problem, that is, like, from an engineering perspective, that's the procedure. And it's not really all that different from doing things like determining whether or not a particular set of structures to be resistant to earthquakes. You'd run different tests in Miami than you would in California than you would in New York, because the feasible assumptions about what you would expect or what you want to be rated for is going to be different. But ultimately, the structural aspect of it is, well, I know certain things about the laws of motion, and I can affect some of its properties by what materials I use and what kind of patterns I use, but then there's going to be certain aspects that I simply can't control, and I'm going to make my designs by evaluating my best worst case scenario. And so we're trying to figure out how to make this as streamlined as possible with cadCAD. But like broadly speaking, people do it mostly to build intuition, or just run experiments and build intuition and make heuristic choices if they're basically just learning. And as we get to more advanced, like again, higher risk systems where the downside of fucking up is bigger, that's where you would literally just build out this configuration, set up an experimental grid that says, okay, I want to test this parameter, this parameter, this parameter. These are the functions I'm going to use in these methods like the price process we talked about. Build out that grid and actually just like run a shit ton of experiments and dump it's almost like the experiment metadata goes in a database, right? You just run a run, it has the facts it has, you collect the results, those are post-processing scorings, and now each experiment just becomes a single record in a database. And you can turn a machine learning algorithm classifier that basically says, for example, was this outcome acceptable or not acceptable? If you have a metric that just, again, the simplest metric is, a measure of a particular run and says, yes, this is acceptable or not acceptable to me, then you can use the a classifier algorithm to determine under what circumstances you are most likely to get an acceptable outcome.
Yeah, that makes sense. I like that workflow in terms of being able to basically say, here are the assumptions in the model. Here's like the bounds in terms of like what we would expect as feasible pieces, and then these are the knobs that we can control.
To be clear, that's why I dragged. To be clear, that's part of the reason I dragged you into things, to try to hopefully start to offload some of that knowledge, because I think of you as someone who pocket for the open source community. Because one of the challenges is that the best way to get people to learn that is to do it in open source, right? It's one thing for us to do it for client projects because it is time and energy, and it's resource intensive. Humans, cycle, work time, mental cycles, like potentially computational cycles, like the complexity of that workflow is high, which is part of the reason why I say that it's appropriate for systems who are for which the risk of failure is, or the cost of failure is high. So you don't necessarily do that in where it's easier to just pick a heuristic and iterate. That is an infrastructure engineering workflow. That is the thing you do for bridges and buildings. Now, I'm coming to the conclusion that certain types of social and economic infrastructure merit that, and I'm also trying to make it easier and faster so that it's appropriate to use for something that's maybe not a building or a bridge. But the kind of idea here is that if we can make it easy enough, and we can sort of respect the importance of these economic systems, that this is like methodologically what we would bring to bear. And kind of closing back to my point, part of the reason I'm excited to work with you is that I'm hoping that by transferring some of that knowledge and having you members of One Hive maybe kind of work through it, that then it'll be in an open source domain where other people can read it and mimic it and apply it, where for me that's a big bottleneck because it's time consuming. It's largely been locked up in projects that are longer term, bigger budget, higher cost to fail. Like we did that work, like we did a year worth of work that led up to that kind of analysis for Filecoin.
I mean, it seems like if the ability to create these models and construct the right assumptions is a skill that is starting to propagate, which we're definitely seeing like the cadCAD community grow and the token engineering methodology grow. If it becomes easier and more practical to apply that methodology on problems that aren't necessarily full on like bridges or like blasting things into space, that's good for everybody. Like lowering the cost of like a good engineering design and thoughtful engineering design is great. It seems like the workflow perspective.
Complexity matters too. Just to be clear, like I said, also Filecoin's order of complexity is like much higher than what we're looking at here. For example, this is not anywhere near as the mechanisms or the family of mechanisms that we were working on for Filecoin.
Sure, and you can design models of varying degrees of complexity depending on how much fidelity or like what assumptions you want to make, right? Like none of these models are going to perfectly reflect reality.
Exactly. Data. So some of the modeling skill is exactly that. It doesn't matter, and like zooming in or out in it to help answer the real questions at hand. So 100%.
But I think that the bar is pretty low in terms of being able to say, oh, we've constructed a model with like a reasonable degree of like assumptions that we can agree on, and now rather than like argue about what the how we should fiddle with the knobs, we can say let's use a much more objective criteria in terms of like what our goals are. Right. And then like let the computer figure it out for us.
Well, and have a meaningful discussion about choices affect the outcome. So, one of the things we've been looking at lately is we've been having a look at quadratic funding and the Gitcoin stuff. And, some of the questions that have arose were like, what is collusion? So like the textbook definition, as it were, or the definition that they had in the QF papers, just like, well, if one group acts in the interest of their group at the expense of the whole. But like, if you look carefully, as soon as the thing saturates, every existing community has this property, because when the Gitcoin round saturates, then everything becomes sort of zero sum. If I donate to you and I'm a new person, then what I'm doing is soaking capital match from another grant, because we're past the saturation point. So like, if you just use this sort of theoretically canonical or basic economics definition, you don't get the fidelity you need to differentiate between a community that exists organically and some actual strategic collusion on the part of a small group of people who take a strategy for moving, like trying to force the funds to move. Because the boundary between those, although it might seem looking at one is that the analytic boundary between those things gets fuzzy. You'll find subgroups like, say, Metacartel, where there's a bunch of projects and a bunch of people, but they're an organic community. But at the same time, if the mathematical relationship between their contributions, this thing is more similar. It's just like it's a group largely funding their own projects, and like as a result, a certain amount of matching is being matched to them. And arguably, you could say the same thing about any other organic community, common stack and token engineering, etc. And so, like, sorry, I'm rambling a bit here, but what we found interesting when we first started playing with this and asking questions of the data was the definitions, although they might narratively seem to have obvious definitions, become very, very sensitive. So you're like, okay, but like, what if I, like, how do I parameterize this in such a way that I have, well, okay, but if I want it to become stricter or more relaxed to move this slice, how do I do that? And for that, you get back to sort of optimization problems, and you can interpret these things like classifiers again. And you're like, okay, but like, if I'm using for simplicity, say, imagine a logistic normally has a threshold, a cutoff threshold. So am I saying collusion is a logistic regression binary classifier with cutoff threshold 0.5, or a logistic regression with cutoff threshold 0.9? And what that would imply is a different tolerance for this. And maybe at 0.9, you only flag collusion for really extreme cases, and everything else, you're like, oh, that's probably an organic community. You see what I mean? Like, we're teasing out this question of even how the metrics themselves become part of these algorithms, and that there isn't necessarily this nice, clean, objective thing. Rather, we have to discuss how our choices impact what that metric counts and doesn't count, or manage the gap between the words we use and what the math says when we apply them as metrics.
Makes sense. To change the topic slightly, because I know, like, I don't know if people have hard stops at the end of the hour or not, but I do want to make sure that there's like a little bit of time to kind of discuss what we're going to try and do next.
I think we should do that.
Yeah, so one of my goals is in January at some point, I basically want to create a proposal for the DAO to implement the new policy. We have like a Solidity implementation that will probably need to be reviewed and potentially like lightly audited. It's like relatively small. And we'll have to kind of provide a recommendation for parameters for kind of the throttle like rate, and the I guess conviction parameters would be less important to decide immediately, but the throttle parameter primarily, and the reserve ratio, and essentially kind of going through this process of kind of bounding the parameters or assumptions that we're kind of not able to control, but like kind of document what they are and what the like ranges that we
up a set of experiments and you run them, and then you examine the results and you interpret them, and you make it come to a conclusion. Although it may be imperfect for any number, that's actually what you're describing. And I think if you were to write out the outline of what you were planning to do, which you said was a stepping stone here, I'd be more than happy to sort of comment or add suggestions to steps. But I don't see a lot of risk to it. You're literally saying the same process I said automatic, but now manually define the things that are not under your control that you're interested in, and the ranges of feasible consideration for them. Set a range of parameters that are under your control and the kind of ranges of consideration you have, and then define the set of metrics that determine whether or not an outcome is acceptable. And then take those things and make a test grid, like an Excel sheet that just says, well, let's run these scenarios. And then you can missing here. Is there anything we should check that's not on this list? And someone might be like, oh yeah, what about this? okay, cool, thanks, let's add it to the test grid. The test grid will be smaller than it would be in the hyper-computational setting, but still just a test grid. You run the experiments and you store them in a place, the results, in a place that other people can recover them. Whether that's notebooks and code files or pickle files, whatever you choose to do to store it, but so that it's referenceable and recoverable. And then you write up some notes and say, well, here's what we saw, and you maybe come back to the group again and say, well, we ran the test. Like, how do we feel about this? And what do we think is more important than what? And here are the trade-offs that we found, and we have to make a choice. And let's make some choices. And then you have this documentation that you preserve that says, we implemented this policy for these reasons. And if someone question it later, at the very least, maybe even by taking some real data, plugging the data that was observed since, and I guess maybe this is the natural thing that follows. If you design a policy this way, then the most natural thing to do afterwards is to collect the data that was generated after you implemented the policy and sort of plug it in and see what happens and see what that tells you about what to expect in the future or what you could potentially do differently.
Cool. Yeah, it sounds good.
So,
I saw the Barada join late. I think you saw the call from last week as the same time, but it was a conflict. I don't know. You want to chime in or have anything to share or questions about what you missed? But we've got a couple minutes, and I'm happy to stay on for a little while as well if people want to continue to sort of jam on modeling stuff.
It's fine for me.
Barada, you're off mute, but I still can't hear you if you're talking.
It's fine for me.
Hey Luke, it'd be nice to kind of go through your parameters in this cadCAD model a little bit more in more detail. I'd be curious exactly how it all works. I've looked at it a little bit, but
I can run through the whole model with you, like now once everybody who isn't necessarily interested in going that deep has a chance to kind of trickle out, or like I just want to be respectful of everybody's time.
Yep.
Yeah, I think I'll have to jump soon, but feel free to carry on. And Boring, if that's all right for you to pass along the video later, then I'll include it in the notes, and anybody who has to jump can catch up on anything else that keeps going in the channel.
Yeah, sure, Jeff. I will try to stay as I can.
Awesome. Feel free to take it away, Luke.
I'll just start at the top then for anybody who's interested. Feel free to stop me at any point. Otherwise, I'll just sort of try my best to explain what's going on.
Sure.
Cool. I'm not using that import anymore, so I don't need it. And I'm going to assume some understanding of cadCAD, but if there's something missing, let me know. But anyways, we start with this genesis state. Values here don't matter too much. I haven't really been changing them significantly. They just tell you what state variables the model's going to have, and they need to be defined up front. Some of them will have actual values. So this is, at the time that I first did this model, was the value of the amount of honey that was in the common pool. This is the circulating supply. It's a bit higher now. There's this market size thing, which is basically I might remove it from the model because it's not that important. We're not using this as a valuation model, but essentially it's saying how big is the market in terms of fiat inflows per month, which is used in the model to determine based on market saturation and growth how much is being converted to honey, the buy pressure as you reach market saturation. The saturation is just a value from 0 to 1.
So that market size, is that more like the size of maybe what we would say the XDI market?
Yeah, I mean, I think like
The total.
one reasonable value, like if you're thinking like right now, which isn't necessarily the case, but like right now it sort of is, the like main market for one hive is trading on HoneySwap, right? Because that's the only thing that's generating inflows right now is people trading on HoneySwap, and a portion of those fees go to purchasing honey and converting it to the common pool. You might say like the potential market for us might be like the amount of fees generated by Uniswap on mainnet divided by 6, because there's only 1/6 of the fees go to the platform. The other 5/6 go to liquidity providers on a per month basis. That would be the maximum market size. Like if we won the market, we outcompeted Uniswap, that's kind of what we would be looking at. Realistically, that market will probably grow over time. And realistically, we probably wouldn't get 100% saturation, but that's like the potential market that's there. So that would be the value you would put here. And then based on some of the other parameters, we may capture some portion of that or all of it, depending on like where we hit in the saturation curve.
I've got to jump, but I also just wanted to mention one more thing. I have a call set with, I think I told you about Sean YDG. I haven't been able to chat to him because we were traveling and such, but he's running also TEC Labs, and every Friday is doing like Python workshops for like pre-cadCAD, and he's also going to be modeling very basic, not agent-based, some models from the TEC parameters as well. But I'm going to try to recruit him for you, and maybe we have some folks from this group that want to come and join TEC Labs. So I think
Can you put the TEC Labs stuff, like the times and like where to find information of it in the Luna channel? Because I could totally join those as well.
I know, I think it'd be great. I'm trying to connect you guys. We were traveling last week, and he's getting more organized, but I doubt if it's happening over the holidays, but he works all the time. So I will find out that information. I have a sync with him on Monday, and then, yeah, I want to bring these two groups together because this is going to be the modelers trained and everything. And I'm also trying to recruit him to do some work on the One Hive stuff with you if he's got the bandwidth. So, but thanks, guys.
Awesome.
And
thanks, Jessica.
I will coordinate async and work on the process for the admin stuff. And I'll talk to you guys on the next. Oh.
Cool. Yeah, probably 2 weeks from now or like after the holidays. We'll figure it out on the Discord.
Cool. Sounds good. Thanks, guys. Let me know if you need anything. Otherwise, see you later.
See you.
Later.
Aragon.
Cool. Yeah. So this saturation value ends up being a value between 0 and 1, and it kind of represents the percentage of the market that I guess we've won. And the production, this is another sort of state variable. It increases based on outflows and a kind of like assumed sort of process of productivity and impact, which we'll get into when we go to that saturation process. So for now, from a state variable perspective, it's just a value that will like get added to as we do outflows and decrease with kind of maintenance over time. Utility is like a function that converts the like production into like a level of saturation on the like market curve. So like there's a process that makes it so that there's diminishing returns to like production in terms of like moving along that curve, and kind of like scales it to like a value between 0 and 10. So the utility will show up in the model as like a value between 1 and 10, 10 being like peak utility. This is something that like I think could be done in various different ways, but it feels like relatively reasonable, and we can kind of look at how that's calculated a little bit later. Price is just a starting price. It doesn't really like it matters actually in terms of like the random walk in terms of price and productivity, so it's actually an important parameter. But it just gets updated each time step based on the price process and impacts other things. And then there's this target price, which is basically an assumed valuation that's determined based on the like level of saturation in the market, the like amount of circulating supply that sort of remains, and the like total number of tokens. So there's like a valuation like heuristic. And then we track net flow and adjustment, which are like changes to the supply, and tracks like whether inflows are exceeding outflows to the common pool, so that we can chart them at the end. And then our parameters, we have the throttle, which is sort of the maximum with the supply policy that can be adjusted each time step. So we wanted to ensure that over time there was like a limit. And so generally you would think about this in terms of like percent per year probably, but it's actually a per time step parameter in the model. And a time step is in cadCAD just like one iteration through the model. It can represent any amount of like time, but in this particular case, based on the values that we've set, represents like 1 month of real world time. So if you like multiply 0.08 times 12, you get 9.6% per year. It would be the maximum issuance rate given this parameter being set. So if like we were using this to set parameters or communicate, we would say, let's set the throttle or the maximum issuance to 9% per year, is what this value corresponds to. Does that make sense in terms of like translating to like actual values that people would understand?
Yeah. Is throttle a word that is commonly used, or a variable that's commonly used?
I just picked it.
Okay.
I don't know if it's that common. And I'm not attached to it in any way. It's just sort of like describe this process of being able to rate limit these changes, so you can adjust the throttle. Variable picking is kind of like, as long as it's like useful semantically to the person that's doing it, it's probably okay. But as more people are working on the model, if there's a better name, we can always change it.
Yeah, I was just curious.
I think a thing that you want to do as the models start to get more like complex is we start spending more time on the equivalent of a data down table, where you like sort of name the variable and describe and sort of say what it represents. That can go a long way to avoid issues with semantics, because ultimately, since the models are still essentially computational thought experiments, if you get a loss in meaning, you lose some of the utility of the model. So I don't think you're at that point now where like you're losing meaning, but definitely as other people would attempt to interpret or use the same model, there is a lot of utility to that. And I know you've already started the way that you've done your documentation, right? You've put the params, the notes next to them. One thing that tends to be nice about notebooks is that they do have markdown cells, so you can even escalate some of that more directly into the markdown if more people are using it. And as you might have noticed in the conviction voting ones, as the models get expressed to audiences that are further away from the work, we'll write whole markdown files just describing the concepts. Not that, again, you should do that right now, but kind of recognizing there's the continuum from the modeler themselves, just kind of playing with new ideas, up to collaborators, up to other users who are stakeholders, up to other users who are like just learning about the system for the first time.
Yeah, and like I think I mentioned this earlier with the wiki, we might have higher level like analysis even than in the model itself. I'm kind of like talking about the outputs or the process. But yeah, that makes sense. Cool. So there's this outflow boundary, which is an abstraction of kind of conviction voting, because we don't actually like go into the conviction voting parameters. But in reality, the level of like outflows will depend on, I guess, how we parameterize conviction voting, as well as like the behavior of people. Like the parameters will determine the like maximum outflow rate, but like the practical outflow rate will be something less than that. And so for the purpose of this model, we just kind of have a scalar value that determines how much of the common pool outflows each month or time step. As like an abstraction of that.
It becomes a black box behavioral model that subsumes the mechanistic elements because you are not bringing it in scope. Of course, it's always possible to have the more like complete conviction voting model, but it's not necessary. And in fact, it's often easier for a model like this to just say, well, although it's a behavioral process, we have better understanding of what's reasonable because of the structure. And this is a neat trick because it avoids having massive complicated models. If the model of conviction voting is enough to tell you, hey, these are the reasonable and extreme values that you observe, then you can ignore it and essentially treat it as a black box in this model. But now you have a good understanding of what ranges are reasonable and which ranges are possible because you got them from playing with the other model. You don't actually have to plug the models together to get the benefit of them.
Yeah, we could potentially also like have like, even if we treat it as sort of a value that we don't have control over here, we do have some control over it because we can change those parameters and like decrease the like upper bound or change
right.
it, even if like.
Yeah, I'm with you. I think the key though is, a lot of the risk with a system is the complexity starts to grow in a way that makes it seem infeasible to do this. One big tricky bit is understanding how to break up the scope of what you're analyzing such that it's useful. And here, I think this was a big leap for you, like a milestone, sort of started getting this model to work as an independent from that one. Because I feel like we started by like working with that one and then moved to reframing it as its own set of questions, which are loosely related rather than tightly coupled.
Yeah, it's definitely helpful. It made it a lot easier. I do want to go back to that model at some point and start playing around with some agent stuff. But that's another topic for another time.
And, I'm also not advocating against combining. Understanding the journey, we're chatting with some people and we have a recording, and I'm hoping to make it easier for others to trace the journey that you followed. Hi, Conrad. Yeah, this is my baby. Hanging out. Anyway, I'm going to mute myself and let you continue. But I thought that was worth commenting on because we have folks who I think are learning by following along. And there was some of the path to here I thought was important.
Yeah.
Yeah, so then we've got this target reserve ratio. So this is what the supply policy sort of aims to sort of correct the like common pool to total supply like ratio 2 over time. So if we set that to like 10%, it would be trying to burn tokens if the reserve is over 10% and issue tokens when it's under 10%. So that's what that parameter means. This valuation ratio parameter, I probably like want to remove this. Like it doesn't really. It kind of just scales the price and market cap in the model, and so it doesn't really like have any meaningful impact on the dynamics. And we're not trying to use this as a valuation parameter. I had originally included it because I was like, okay, how do we construct an idea for the price that like maps to sort of how people would actually value a token? And often there's like a kind of ratio between the inflows or earnings to the actual like token itself. So it plays that role, but I wouldn't worry too much about it because it doesn't actually change the dynamics. And so it probably makes sense to even just remove it as a parameter because it's not really useful in terms of answering those questions. We can just have like a fixed constant for that.
Sorry, just I have a note here. So doesn't valuation ratio, if you use it for aggression band, so you can predict the market cap of honey. So yeah, maybe you can use the valuation ratio to predict the market cap of honey to make the aggression band for the honey market. I mean,
Yeah.
it's not necessarily it's like not useful. I think it's useful, but I'm not sure why.
Yeah, I mean,
so
so what I was saying by like it allows you to kind of scale the like market cap or price based on all of these other assumptions, but doesn't really change the dynamics. Is that like if I run the model right now, and you come down and look at
you bit to what does mean to?
sorry, I'm just waiting for this to load. So we have this price and we have market cap. So
Yeah.
if I run this, we've got different scenarios based on the different productivity things, but you end up with like a trend for market cap. And this is based on the like pricing policy. And if I go back and I change our valuation ratio to say like 100, we're going to see basically the same results, but the numbers are going to be scaled up by approximately that amount. Maybe we'll see different numbers.
It's sort of the textbook example of discovering insensitivity. The fact that it's just a linear scale factor means that it's not a particularly useful parameter in this version of this model. I think back to your previous discussions, if we did incorporate HoneySwap more explicitly, it might actually be very important to look at it because it would play on the dynamics for how people traded, which would result in, you know, slippages and changes in price and etc. So, you know, at the level that we're currently at with no explicit HoneySwap model, I think, you know, Luke's right. It's a scale factor. It doesn't really do anything. But I can see how, as the model grew in complexity, if we did the thing we discussed earlier and someone made the swap model, a very natural would be to plug those two models together, at which point the valuation ratio might be an important coupling coefficient.
I see. Interesting.
Yeah, and the reason that I would say like I probably want to remove it is because it doesn't affect the dynamics as much. By removing it, when we do this analysis of like these parameters that we care about, and we have to do iterative experiments and compare to try and find the best parameters that we can control, it's like one less dimension, which reduces the amount of like work or like inference that we have to do. So yeah, I'll probably like factor that out of the model, or I'll just like leave it as like a fixed value in doing the analysis. I'm not sure yet. Then we have this like productivity parameter, which I actually like. This is one of the biggest kind of assumptions that we don't really control. That has the biggest impact on like whether number goes up or number goes down. Because essentially it's an abstraction of saying like for all of the outflows that we have, and I've assumed that they're going to be used to promote promote the utility of what we're building, build products, promote HoneySwap, and they may result in some like marginal increase in utility. But they're scaled based on this value, right? Like if we're more productive or less productive, outflows are more effective in kind of moving that needle in terms of making progress in terms of market share. So we can kind of span a range of productivity values, and if we pick without assuming how productive we're going to be, if we pick the parameters that like are successful across the largest range of productivity values, it's probably a good sign, since we don't really know how productive we're going to be. We know that if we optimize for productivity, we'll probably increase our chances of success. And if we like are successful in the largest variance of productivity ranges, we're probably in good shape. But yeah, it's a pretty abstract parameter and just sort of scales how outflow goes, or how outflow turns into production.
So it appears to me that there's like, and I don't know what these terms are called, but there's parameters that are assumptions, and then there's parameters that are, values that we're trying to identify what the best parameters are based off of modeling, and then there's some parameters that I guess are just not as critical, but maybe they're assumptions as well. I don't know. But
yeah, there's only categories, but you're right. Some of them can be insensitive. That's the right distinction, though. You need the concept of controllable and uncontrollable. You are working on one set, and the others are just part of the definition of the problem.
Yeah, so the uncontrollable ones are the ones that I would say that we probably need to. I wonder if there's a way to kind of flesh those out a little bit more, because when we, bring this forward in January and whatever the model ends up presenting itself as far as the policy, that's the question that's going to be asked is, how are these uncontrolled variables selected? And I think Z, you referred to it a little bit in the price modeling one, where it was kind of a correlated, uncorrelated. You always have a and you get to it down here, the pole versus variance of 75 and negative 25 or something like that. Yeah, positive 1, negative 1. There's always this, I guess, movement towards a positive growth, right? So almost, I guess you're modeling what the best scenario is, but all scenarios are going to be positive if you have a natural progression towards the positive, right?
It's not necessarily the case, actually. So, like, if we look at the data that's produced, see if this shows up here. In these cases, depending on some of those other parameters, you have instances of variation in terms of like the path that the price takes, because the price impacts productivity and impacts other things. And so you have instances, depending on what these values are, where you don't always go up and to the left. Sometimes you'll actually reach saturation, and then price fluctuations cause productivity to go down, and then you lose market saturation. And so, like, what we're saying here in terms of this correlation is that, like, more often than not, the randomness of prices are going to be pulled in the direction of some like fundamental valuation, which is sort of what this price target is saying, is like there's inflows that are happening each period, and they're buying tokens, and there's some like fundamental like valuation based on the state of the system, and we may or may not agree on the exact mechanics of that. Like, that's an assumption of the model, and we could try different assumptions there for sure.
I want to make a comment about this too, monstrosity, and that's what I'm talking to, right? I think it's really important when we drill into these things to be careful about what. Sometimes it's important to have what I would call a clear modeling like surface, which means it might actually be less specific and lower dimensional, but easier to track for. So if we have a concept like how useful people perceive something to be, and say we give that a unit, like it's, again, however you find the unit, it's actually easier to have a lower dimensional, like phenomenological but unit-wise well-defined measure, and just say, let's consider this concept we created with these units over this range, and sort of justify that range as sort of again, it's sort of like a modeling surface, or like almost like an attack surface, in a sense that if we make it nice and small, and we say it's this one variable which captures on the other side of it a lot of complexity that we don't totally understand, it's actually easier to test than if we try to make a really high-dimensional, really descriptive representation of the same phenomena. Now, that's not always the case, because we might have lots of data, but in fact, drilling in on these assumptions isn't just about more detail. Sometimes it's about being really smart about less.
Right. You could almost, rather than making it a variable, going away, coming towards, or going different directions, you could just say a linear a linear trend of your price decreasing, run the model, a linear of the price increasing slightly, and then a linear trend of it increasing rapidly. And then what is your, given those three scenarios for price, what is the best model? And then you're not assuming that price is always increasing. And you're not even considering drift or variance or variability or any of that stuff. So that's pretty simplistic. I'd be curious how something simple like that would.
What would be your what would be the question that you're answering by saying that price is just always going to go down in terms of these things? Because your assumption there is so strong in terms of price, and the things that you're trying to optimize for are trying to optimize for price and market cap going up, right? Like the success criteria is based on that. So you just assume that it's going down.
It doesn't
as
have
opposed to potentially going up or down. I guess what would be the thing that you're using to evaluate any of the questions or decisions there?
So I guess in order for you to know worst case scenario, I guess it doesn't necessarily have to be the end model that you use to model your policy, but to see how the model optimizes to that scenario would give you the worst case scenario. And so probably realistically, worst case scenario is just a completely random value, right? Where you don't know if it's going to go up or down versus just a constant negative trend.
Well, you mean in terms of worst case scenario for the issuance rate then? Or
well, is issuance rate dependent upon price, or is it not related? And if it's not related, why is it in the model? Not to be brash, but
yeah.
it is related though, right?
So it is related, but it's related in a relatively complex way. So the way that it's related is that depending on the price, we have we have this inflow calculation that converts the level of market saturation to a level of revenue essentially, and then the revenue turns into honey that gets put into the common pool and counterbalances the outflows. So we expect price to increase over time if our inflows exceed our outflows. We expect our outflows to be more productive at higher price because the actual value of production that we're paying people to do things for has increased for the same amount of tokens. And so price has an impact on several parts of the system that result in production and changes to the supply policy. And so it's important to have price in the model for that reason. And it's also important for price to be assumed to have some behavior that is relatively realistic, right? If we say that price just goes down and is completely unrelated to anything else, then the system isn't necessarily behaving in a realistic fashion. So I think this is sort of earlier on in the conversation, we talked about the assumptions that we make that we don't really know exactly how they're going to behave. They're uncertain. We don't know how price is going to behave. There's lots of complexity there in terms of factors. We can make a best case sort of assumption, and it can have a range of parameters. We can make multiple assumptions in terms of the suggestion to use a method for determining the price as opposed to one thing, and we can compare the model under multiple assumptions for how price behaves. But we want those assumptions to be realistic or feasible in some way. And I think that like in the case of saying price just is completely unrelated to any of these other parameters in the system, would be something that would probably fall in the like either unfeasible or unrealistic in terms of the dynamics of the system, that we wouldn't necessarily want to consider it from like a.
Yeah. So I don't think that price being negative is unrealistic, and I do believe that price is related. So it can be realistically negative, and also related. So
But we're saying that price can increase or decrease based on the state of the system currently, right? But like saying that price is linearly decreasing over time,
regardless of the system,
regardless of the system doing anything.
This is an exogenous versus endogenous assumption. So like you can have a model and there are price will decline, but it's not an exogenous assumption that we're not driving it with a decreasing price. We're talking about this system as having, let's just say like trajectories where it's decreasing. Like those will arise based on the particular model playing out. And in fact, if anything, we're curious about which of the assumptions that are under our control or not under our control, what kinds of things result in that. So maybe there are certain scenarios where that happens a lot, but we don't know which ones they are, precisely because we didn't declare that it will go down. We're interested in seeing in which scenarios that issue arises, and detecting that and saying, we don't want to be in one of those scenarios. How do we avoid it?
So if the negative is unrealistic, the positive is also unrealistic.
Well, no, I don't think either of them is exogenous. I think that we're talking about, and this is the difference between when we talk about price process versus, we're not making assumptions about the trajectory of the price. We're making an assumption about the distribution of the stochastic process. And I guess, at one level, it's sort of in that we are doing a distribution that's determined by this, expected growth or contraction rate, which I guess, to be fair, is a bit more like going up or going down. But what I would I would imagine is that even that expectation to be some sort of function of the other variables, right? That we're not saying that it's growing or shrinking. We're saying that the expected extent to which it's growing or shrinking is a consequence of the other states. And I mean, maybe we're not quite at that point yet, but the way that I usually look at coupling price into something like this is to keep it as a random variable, but have the random variable's distribution state dependent. And I think I shared with Luke, and you should maybe look at ZX's master's thesis was then fleshed out into a journal paper, and he did a little bit of work where he was defining state-dependent stochastic processes. So the stochastic process itself was, a random variable, but that the distribution of the random variable was state-dependent. And that's, I think, what we're really aiming for in a lot of these models. Like, we don't know, we think of it as kind of random and noisy, but actually the expected value of that process might actually be state-dependent, not just the same every time you flip it.
So I have a few questions around that. I also want to try to state this in simple terms to see if I understand what you're describing. Because I think this is the stochastic process you were referring to last week, right? So are you saying that there are two different things that kind of matter? One, the environmental process, which could be described as market swings and cycles, how that moves, which kind of defines a broader kind of range. And the is the kind of fundamental drivers of value, which is how you might value the price of honey within that market specifically. And so you could say, as the market swings up and down, that could define the mean around which the honey valuation model then oscillates depending on our fundamentals and some randomness. Yeah. So that way the mean is going up and down, but then we're still modeling around that mean some specific parameters and models that can influence what that price would look
I think
like.
That's a good way to think about it. The thing is that in if you imagine markets as sort of constantly regressing to some low frequency trend, like we don't know what that low frequency trend is, but it's fundamental in nature. but it's low frequency. And then there's something a bit more random feeling or high frequency in nature, which is maybe a little less fundamental. It's a little bit more speculative, short-term gains, again, so high frequency component. In a way, what we're saying is that if the expectation of the random variable something fundamental in nature, all we're really saying is that the system is kind of on one hand, it's regressing to the mean or regressing towards this fundamental phenomena. At the same time, it's being perturbed or randomized by this other component. And maybe that's a little bit hard to grok, but one way or another, we want to capture both at the same time. The idea that some stuff is random and unpredictable and surprising and might come from something other than the fundamental principle, but we want both to be acting. Both, you see what I mean?
Yeah, definitely. And so that way we could say, like, okay, within the range of how our own productivity impacts demand and price, here's that range, and then we also can say, well, within the range of the market, that would also determine where that sits. And then so potentially if the market's going down but our productivity is going up, there would be a certain amount that we could expect. And then if they're both going up, then it would kind of change. And so our goal really would be then to improve our productivity within the range that we have so that we can stay at the top end or even grow the top end of what our fundamentals can be, while understanding that that is going to fluctuate within market cycles. Is that what you're saying?
Yeah, I think that's right. I'm going to try to use the example that's in that paper a little bit, so that it's a reference point for you to look at. In that journal paper, the process in question was a arrival of new supply and new demand in a market, not necessarily a financial market, but even a service or commodity market. So there's an amount of buy side, an amount of supply side, and the arrival rates were. But when the system had lots of extra supply, then you would see essentially an incentive or an increase due to price generally, an increased incentive for people to come sell side and vice versa. So it was a model of this thing we've observed in the real world, which is, okay, well, even if arrival of new supply and new demand is a random process, there's a sort of fundamental we can expect where when there's lots of supply and not enough demand, through a price process, you might find an increase in the arrival of supply. And I forget how he exactly modeled it, and I'm not recommending you take his exact model. My point is that the concept of supply and demand is present, but not in a deterministic way, more in an expectation way. That the random variables are flipped for the relative supply and demand, but they're chosen in such a way that is tied back to the fundamental concept without dropping it into this deterministic, supply demand curve model. So it's like a mixture of the fundamental notion of supply and demand and the stochastic notion of the arrival process in time. The probability of the arrival of a certain amount of new demand or the probability of a certain amount of new supply was a stochastic process. And Conrad is very, very happy to talk to you guys. But anyway, so I'm recommending just even poking through that because it, although it's, again, not something to copy-paste per se, he did a reasonably good job explaining what he modeled, why, in his case, because he wrote it for an academic paper.
I just wonder if there's, we've got existing examples. A lot of this is theoretical, and it's got good concepts, and it's almost like you can, what they're mapping out are scenarios that we actually have real world models for. In a sense, it's just kind of difficult to pick and choose. Like, for instance, what is the crypto market doing right now? I mean, you could essentially use that as our environmental, market, rather than using a generic theoretical, which can be applicable
two comments
to.
on that though. The crypto market models don't tell you anything between the fundamentals and the noise. They're really just noise process models. So to be clear, I've absolutely used them. We've fit stochastic processes from historical Bitcoin and Ethereum prices to use on exogenous drivers. But if you're trying to correlate the fundamental aspect at all, then you're stuck with some theory related to the specific system in question, because basically nothing in crypto today is mapped to any sort of like fundamental. It at closest thing you could do would be to look at things like, you know, Bitcoin hash power relative to Bitcoin price, and maybe look at the way that halvings inject like shifts. But it's hard to map those to the specific kinds of use cases we're facing. So, you know, on one hand, I really like using Python actually precisely because you can pull in and fit machine learning models and stochastic processes. But on the other hand, there's a limit to the analogies that you can make when you're trying to address fundamentals. So the answer is sort of yes and no. It depends. You just kind of have to feel out which data you have, what process you're dealing with, and how well the data is available could be analogized to what you're doing.
Yeah. Hey, Luke. So what was the most recent parameter you just entered in on this one?
So I was just adjusting the like variance and the like pull parameters to kind of explore.
And is it the productivity values the 3 subsets?
Yeah. So this is like really low productivity, medium, and high. Or if you want the precise values, even though it's like an abstract kind of thing, is 0.1, 0.5, and 1. But just kind of laying them out so you can see them side by side. But
Right.
the interesting thing, kind of to your point about the pricing assumption, is that like these dots here, if you can see them, are based on multiple runs with different random variables. So you can kind of see the variance in terms of outcomes of market cap and like kind of the trend. So this is a trend line across those 10 runs for this value. And so you can kind of see the distribution.
So it does say we have to be productive.
It does say we have to be productive, yeah. Like if we're not productive, bad things happen, or good things don't happen, I should say. If we are...
That's a good sanity check. I'm usually inclined to say you always should run scenarios with shit, because if your model shows good things when good things happen, but shows good things when bad things happen, you're probably busted. You're just like, good things, yay! If you can't show that shit goes to shit when you don't do what you're supposed to do, then you probably don't have a very good model.
Either that, or you've picked a really good parameters. You've really hit it spot on.
Yeah, I mean, the other interesting thing, and like we saw this even before I added the stochastic process, and the closer we get to, like, I guess 100%, the closer we get to the previous process, is that like the more productive you are, the like higher you or the quicker you reach the saturation point, if you do reach the saturation point. If you're not productive, you don't ever reach that saturation point. But there is sort of like a like curve in terms of hitting those points at different times, and depending on like the price action, you may see that those inflection points at different times or not at all.
Yeah, I'm just more inclined to like run variables that are as close to that 0.1 and 0.5. You know, keep on, finding. So obviously, there's a couple more data points between 0.5 and 0.1 before it just, because there's a pretty big step change there, right?
Yeah.
Right. Oh, so finding out where that kind of falls, whatever that value is, and then adjusting your parameters to see what the most desirable outcome is with the least amount of productivity.
Yeah. I think I was going to say that's where I was going to go towards, thresholds, and just remember productivity is abstracted here, so we can only really do a sensitivity analysis and say how important productivity, or how tolerant are we to decreasing the productivity and try to look for things that are more tolerant, but also keeping in mind that, that is always a possibility. And if in the most extreme, non-productive state, you wouldn't expect this system to perform very well. We have to be at least a little bit productive in the sense that we produce something of value for the system to continue to live. But to your point, I think this is more of a sensitivity analysis because it's sensitivity to a concept. The concept is well defined, meaning productivity. Obviously, you can be productive or not productive, but the actual manifestation of, well, is our current productivity a 0.1, a 0.5, or a 1? What does that even mean? And that brings me back to the point before about creating some documentation and explaining how you've envisaged it. And if you have created a concept that you're using, like with units, then describe those units and say things like, I mean, this is a rate of, production. Hi, Conrad. Yeah, I know. It's so boring. So boring. Daddy likes to talk about math. Anyway, I'm gonna have to go in a sec. But the point I'm making is that when we construct these abstract variables, it actually goes a long way to give them and talk about how they might be measured. Because although they may be abstract today, you may end up turning them into a kind of metric that you can use in the future. Like, for example, if we're talking about activity in terms of, I don't know, like some sort of unit of utilization per unit of expended effort. Eventually, that might be that abstraction might be mapped to something measurable and inferred. Yeah, okay, we can't measure it exactly because it's a concept, but as long as we've constructed it with units, we might actually eventually be able to, make a measurement and use it insofar as it's useful, right? It's still not an absolute quantity, but a revenue later as a function of expenditures now is a kind of efficiency that you could eventually measure. Future revenues as a function of past expenditures.
So we might never reach 0.1 productivity ever because our concept is not laid out pretty clear. So
I mean, the idea of a productivity of 0.1 doesn't necessarily it doesn't have a mapping to a real world value that we can understand. It's probably something that is very variable on a per proposal basis, right? Some proposals will end up being really, really high leverage. Others may not. We might get a lot of value for one, but we know that in aggregate, if we have a bunch of proposals that produce nothing of value, our overall productivity is probably low. And if we're highly efficient in terms of the funds that we allocate in terms of producing things or producing demand in general, our productivity is probably relatively high. And the model lets us test the sensitivity to that parameter or that concept. And if we know that it's highly sensitive to that concept, maybe prioritizing things that allow us intuitively to increase our productivity, like maybe we work on milestones or escrow type workflows, or we work on our sort of social norms to evaluate proposals and provide more scrutiny to follow up or objectives in terms of funds going out. We know that might have a larger effect on the actual outcome. Because we know it's sensitive to that.
Beyond that, I'm saying that we can also work towards making it less abstract. So, for example, if each proposal was thought of as having even some very proposal-specific success metrics that were binary, either achieved or not achieved, then one interpretation of productivity is the frequency of the success rates, or even a weighted frequency by money spent. So you could get a 0-1 value that is measurable, that starts to fulfill the function of this variable. And even though it doesn't exist today, we know that the concept exists and that the system is sensitive to it. It might actually behoove us to flesh the concept out within as a way of aligning on measuring our own success.
But how we can link our productivity to our successful in the proposal. I mean, we could have be successful, but the successful doesn't measurement to our productivity. I mean, it could be very successful, but the productivity could be 0.001. I mean, it could be just very low productivity.
So Born,
the measurement. Yep.
I'm sorry. So I'm curious what how you're evaluating productivity. It's in my opinion, it's not necessarily the price of honey or even revenue versus expense. It's just simply supply and demand, right?
Yeah.
And so anything can drive supply and demand. Well, supply is pretty obvious, but demand, anything can technically drive demand. There's just more variables than simply whether or not we're bringing in revenue in faster than we're spending it.
Yeah, but I'm using the honey market cap to.
Okay.
Yeah, so because our supplies keep changing, so the price could be going down, but the honey market could be going up. So it doesn't mean
Right.
yeah. So if the honey market is going up, that means the project is successful.
Yeah, guys, I think we're missing a key point here, that there's actually supply and demand dynamic going on here. One of them is the supply of the labor force. So, like, functionally, OneHive does projects, and projects drive some sort of more non-financial output, and the non-financial output influences people to believe in this system and affects the demand. So we actually want to reason about, even just at the question of the modeling, are we talking about the efficiency in we spend money, we do work is then converted into attention, and attention is converted into token demand. So even if we simplify it dramatically, there's still a sort of unit conversion sequence baked in here, right? Labor produces software, projects, or outputs. Conrad, hi. I know, still boring. So that labor that is funded, right? It produces some byproducts, which are abstract. They're not money directly. They're just byproducts. Byproducts can create revenue, but they can also create attention, and attention can create demand for the token.
Exactly.
So if you were to start to flush it out, there's actually a lot more supply and demand than just supply and demand for honey. But again, we have to compress some of that away. We got to be careful with how we interpret these productivity, all of that.
Yeah, that's exactly what I was saying. I've got to drop off, guys. It was a really good conversation. Really awesome stuff. Thank you.
Yeah.
Thanks for your time.
I mean, I think this is probably a good time to stop it. We've been on this call for 2 hours.
Yeah.
Thanks, it's been a great discussion, and look forward to kind of continuing it.
Yeah.
And thanks everybody for the time.
Yep. Thank you, Luke.
Thank you.
you, Matt.
Thank you.
Thank you, everyone.
See you guys.
Thanks, everyone.
See you.
Bye, guys.